Now I will start bubble sort. So it is the most simple form of sorting and the basic sorting technique. So starting now, bubble sort. Okay. So if I have this array with me. 7 4 5 1 6 and 8. Okay. Now I have to sort this array in ascending order. So, so the process of bubble sort is like this. First you compare these two elements. 4 is less than 7, so exchange 4 and 7. 5, 1, 6, 8. 4 and 7 is exchanged. Okay. Then compare 7 and 5. Compare 7 and compare 5. Okay. 5 is less than 7, so exchange. Now compare 7 and 1. 1 is less than 7, exchange. Now compare 7 and 6. 6 is less than 7, exchange. Compare 7 and 8. 7 is already less than 8, so don't do anything here. Okay. So it is the first. So this is the first iteration. Okay? First iteration. So we can see that at the end of the first iteration, the largest number is at the last position of the array, right? So 8 is at the last position of the array, right? So that means 8 is sorted. So 8 is now at the appropriate place. Now I have to apply the same procedure in this part. So now I have 4 5 1 6 7, right? So, 4 so 4. Let's try the zoom, white bottom zoom. Share whiteboard. Okay. Now, so after the first iteration, my array is 4 5 1 6 7 8, right? So 4. After the first iteration, my array is 4 5, 1, 6, 7, 8. 4, 5, 1, 6, 7, 1, 6, 7, 8. Okay. So it is the first, after the first iteration is my, now this part. I have to apply the same procedure to this part, right? So then again compare 4 and 5. 4 is already less than 5, so don't do anything. So array remains unchanged, right? It is problem. There is a problem in whiteboard. I cannot. I actually try to use the whiteboard, but it seems somehow it is very uncomfortable for me. Uh, so so I am sharing my screen again. Okay. So now, so what? So my array is after the first iteration 4, 5, 1, 6, 7, 8, right? 4, 5, 1, 6, 7, 8, 5, 1, 6, 7, 8. 8 is already in the appropriate place. Okay. Now I have to apply the same procedure in this part. So compare 4 and 5. 4 is already less than 5, so don't do anything. So the array remains unchanged. Now compare 5 and 1. 1 is less than 5, so exchange. Now compare 5 and 6. 5 is already less than 6, so don't do anything. Compare 6 and 7. So exchange. 6 is already less than 7, so so don't do anything here, right? So that means this this iteration is now finished, right? I I don't have to compare 7 and 8 because 8 is already in the appropriate place. So my comparison will stop at 7. Okay. That means now 7 and 8 are at the appropriate place. So these are sorted. Okay. Now I have to apply the sorting in this part. So I take 4, 1, 5, 6. You can see that at the end of each iteration, I have to compare the total numbers which is actually one less than the numbers in the earlier iteration. That is, so originally I had to compare six numbers. Then after the first iteration, 8 was at the appropriate place. So at the next iteration, I compare five numbers, right? So now I compare four numbers, right? So now compare 4 and 1. 1 is less than 4 exchange. Compare 4 and 5. 4 is already less than 5. Compare 5 and 6. 5 is already less than 6. So after this iteration, iteration 3, I can see that 6 is at the end, right? So now 6, 7, 6, 7, 8 are now sorted, right? This portion is now sorted, right? Now apply the same procedure in this part. So 1, 4, 5. Compare 1 and 4. 1 is already less than 4, so don't do anything. Compare 4 and 5. 4 is less than 5, so don't do anything. 5 is now adapted, so 5, 6, 7, 8 are now sorted. So this part is sorted. Then I have to apply the same procedure in this part. Already 1 is, so 1, 4. Already 1 is less than 4, so don't do anything. So 4 is also sorted, right? So the entire array is sorted in this way. So in this way the entire array is sorted now, right? So it is the procedure of bubble sort. Now you write the code for it. Our name is like this bubble. Actually, each time I am seeing that the largest number is bubbling at the end. Okay, but the largest number is bubbling at the end. So the name is like this. Okay. So actually, uh, the bubble shot code is like this. Machine group. I declare an array of size 20. Or I hard code this array. Okay, for now I hard code this array. I don't have that much time to again take input, and so suppose the array is 5, 2, 3, 1, 7. Okay. So now I declare variables I, j. Okay. Now for I 0, or I take some array. So suppose the size of the array is 20. Uh, printf enter how many elements, and I will n, nf n and person n for I0 I less than n, I plus plus, I input the nf, I give here another printf for ease of understanding. Enter the numbers, scanf, smd, %n. Okay, now let's see. Now start sorting for I is equal to 0, I less than n, I plus plus. Okay, for j is equal to 0, j less than n minus I, j plus plus. Why it is n minus I will tell you. Okay, it should be n minus 1. It is n minus 1 minus I. So now it is a simple swapping concept, right? So declare another temporary variable temp. Okay, so now here what I will do, temp is equal to arr j. Okay, now if if arr j greater than arr j plus 1, you should always remember about the indentation. Okay, that I have told you in the lab. You should always maintain the indentation of your code. Okay, change is equal to, so if error j is error j plus 1, change to error j, error j is equal to error j plus 1, error j plus 1 is equal to 10. Now let's check whether they is sorted or not. So just copy and scan it. Sorry, I am done a mistake. Scan it. ARR I, right? Okay. So elements start sorting. Okay. Here it is printed. Let's check. Okay, enter 6 numbers: 2, 1, 4, 5, 3, 7. Oh, interesting is there. 6. So 2, 1, 3, 7, 5, 6. 1, 2, 3, 5, 6, 7. Now I will explain the program. Okay. Let's open Paint. Actually, I am very comfortable to use Paint. Okay, because uh, here I have everything in place. I have eraser, I have everything, and also I like Paint from my school life. Okay, so I like to use Paint very much. Now, yes, suppose my input array is this: 7, 4, 3, 8, 1. Okay, this is my input array. Okay. Now I have to sort it in ascending order: 0, 1, 2, 3, 4. Okay. Now, so here n is 5, right? So first I is 0. Okay. Now j is also 0, right? Now I am comparing if ARR j, if ARR 0 is greater than ARR 0 plus 1, is ARR 1 or not. Okay. So that means ARR 0 is here 7, ARR 1 is 4, so it is true. 7 is more than 4, right? So this if block is now true. If block is now true, right? So control goes inside this if block, and there is a swapping logic here. So I am swapping 7 and 4, right? By using this block of code. Okay. So that means 4 and 7 are swapped. Okay. That means 4 and 7 are swapped, right? Now again control uh, goes back to the for loop. Now j becomes now I is 0, j becomes now 1, right? Okay, so it is 0, 1, 2, 3, 4. Okay, now I will check ARR 1 with ARR 2. Since 3 is less than 7, so I will interchange 4, 3, 7, 8, 1. So again it goes back to this for loop. Now j becomes now 2, right? Now j becomes now 2. Okay, so I compare j with j plus 1. That means 3 and 8. 3 is already less than 8, so no issues here. Okay, right? Okay, so now after that j becomes 3. I compare 3 with 4. 1 is less than 8, so I will exchange now, right? So at I0 and G3, I am exchanging now 47318. Okay, so I can see that now my largest number is at the end now. Now again, again it goes back to the for loop, and j now becomes 4. But what is n minus 1 minus I? N is here 5. 5 minus 1 is 4. Now j becomes 4. So this condition is now false, right? N is 5. So 5 minus 1 is 4. Now j is now 4. So then that means this condition is now false. J is not less than 4 now, because j has been incremented to 4 now, right? So so can you understand how why here it is n minus 1? Because see, I compare with 8 and 1, right? Okay, so after, if j is not, if I write here only n minus I, then so and then at the next step j becomes 5, but then I will try to compare j with j plus 1, but there is no case here, right? Okay, so here it is mentioned as n minus 1. Okay, okay, done. So after, until now it is first iteration. So after first iteration, I have this already at the correct place, 8. Okay, so after that I have to only compare 4 elements, that is 1 less than the earlier, right? 4, so I have to only compare this 4731. So but then it goes to the outer for loop. So I now becomes 1, right? I now becomes 1. So now for j0, j less than n minus 1 minus I, right? So now I am starting the next iteration, right? So I have 4, 7, 3, 1, 8. 8 is already placed. So I have now compared these 4 numbers, right? So now what is n minus 1 minus I? N minus 1 minus I is now 1, n is 5. 5 minus 1 minus 1, that means 3, right? So 0 to 3, right? So for that reason, whenever I complete one iteration, then I increment I and subtract it from the n minus 1. I increment that is, I subtract I from the n minus 1, so that the next for loop will compare one element less than the earlier iteration. Understood? Okay. So why it is n minus 1 minus I? Because to decrement the number of comparisons. Okay. Okay. So now again in this, by the same process, 4 and 7, 7 and 3, so 3 will be exchanged now. Then 1 7, so 1 and 7 will be exchanged. So 7 is at the end of the array now, so that is now 7 and 8 are already sorted. So in the next iteration, I will compare 4 3 1, right? So then again I is implemented. Okay, so again I is implemented. Then 4 and 3, 4 and 3 is compared, 3 is less, so exchange. 1 and 4 compare, 1 is less, so exchange, right? That is now these three are shorted. Okay, now I will compare 3 and 1, right? So since 1 is less, exchange 1 3 4 7 8, right? So now entire array is now sorted. Okay, so in this way bubble sort works. Understood? Now can you say why the outer loop is up to n minus 1, not n? Because after all the shortings, I will have, see, at the last step I have only 3 comma 1, right? So I exchange and the entire array is shorted, right? So now I don't have to again implement I and compare, because already these things is shorted 3 and 1. So that means I don't have to go until 3, right? If I have only 2 elements at the end, then if I exchange, my sorting is done. So I don't have to go till the single element. That's the reason I made the outer for loop is up to n minus 1. Okay. So if you have any problem in understanding, then you can call me, or I will give one special class to clear all the doubts about sorting. Okay. So you go through all the sorting and searching and sorting videos, and collect all your doubts, and I will give you one special class where you can clear all your doubts. Okay. Now let's calculate the time complexity of this sorting. So I can see that the outer for loop is up to n minus 1, and the inner for loop is up to n minus 1 minus I, right? Now that means that means so I will calculate the time complexity of best case and worst case. So what is the worst case input? If I have to sort the array in ascending order, then my input worst case input will be this: 7, 6, 5, 4, 3, 2, 1. So every time I have to exchange, every time I have to exchange, every time I have to exchange, right? So this is the worst case input for me, right? So now the outer for loop up to n minus 1, and the inner for loop is n minus 1 minus I. So as a whole, I will need n minus 1 into n minus 1 minus I in I number of iteration. So then here there will be an n square term, right? So I will always consider the higher term to calculate the time complexity. So worst case time complexity is big of n square, right? Now base case. What is the base case input? If the array is already sorted, right? So 1, 2, 3, 4, 5. Though the array is already sorted, but I can see that all the condition checking, I can see that all the condition checking is inside the both the for loops. So whether is array sorted or not, these two for loops will always will actually always execute, right? Whether the arrays are sorted or not, these two for loops will always execute because all the condition checking are inside the for loops, right? So in the base case also the time complexity is big omega, big omega of n square. Okay, yeah. Now, so in case of bubble shot, you can see that both best and worst case time complexity is n square, right? But there is a particular way to decrease the time complexity of uh, bubble shot. Okay? So if I suppose my input array is 1, 2, 3, 4, 5, right? Now at the first iteration, there is no swapping, right? At the first iteration, there is no swapping. Now, if I can use this fact that if there is no swapping at the first iteration, then I will not proceed. I will break from the program. So, once more, if the array is already sorted, then I can see that there is no swapping at the first iteration. So if I find a way so that if there is no swapping, then I will not proceed. I will break from my code. Okay. So let's check how to do it. I will have one tag called swap. The initial value is 0. Okay. Now in the outer for loop, I, if swap is equal to 0, now if there is a swapping, what I will do, I will just implement swap plus plus. Then here, if swap is greater than 0, then break from the program. If swap, sorry, if swap is equal to 0, then break from the program. Okay. Okay. So now check how many. So if I print the number of rounds, okay. So uh, printf number of rounds percent t I. Okay. So I am checking how many times the outer loop is executed. Now let's compile once so that uh, suppose 6 elements, 2, 1, 6, 7, 4, 8. So 1, 2, 4, 6, 7, 8. Okay. So number of rounds is 2. Whereas after sorting of this, okay. Now, so my input is I am noting down the input. So my input is here 2, 1, 6, 7, 4, 8. Okay. Now if I comment out this, I comment out this. Let's see how many rounds are there. 6 elements. One, sorry, no, running. So my input was 2, 1, 6, 7, 4, 8. So 6 elements. 2, 1, 6, 7, 4, 8. So you can see that if I comment out that code, sorting is okay, but number of rounds is 5, right? So that means here time complexity is increasing. So by using sort variable, I am decreasing the time complexity a lot, right? So what is happening here actually? So let's explain that. 2, 1, 6, 7, 4, 8. So 2, 2, 1, 6, 7, 4, 8, right? Now, so initially I is 0. Initially I is 0 and j is also 0. Swap is 0. Okay. Now, so that means I am comparing with 2 and 1, right? That means 2 is more than 1, so condition is true. So I will swap, right? I will exchange 1 and 2, right? So 1, 2, 6, 7, 4, 8. Okay. Okay. And swap is now incremented by 1, right? Swap is now 1, right? Okay. So this condition is false because swap is now 1. So again, I is again now sorry. So inside the for loop again the j is now implemented. Now so instead of j is now implemented. So I will compare with 2 and 6. It is already less. So then compare 6 and 7, already less. Compare 7 and 4, then you exchange, right? You exchange 4, 7, right? 4 and 7. Then again compare 7 and 8, 7 is plus. So no excuse. So at the end of the this 8 is there, so it is the largest number, right? Now again, so this for loop now ends. So now I will check whether swap is 0 or not, but swap is now, swap is now more than 0, right? Swap is now greater than, swap is now greater than 0. So this condition is false. Now so it goes back to the outer for loop. Now I becomes now 1, j is 0. So compare 1 and 2 less, so don't exchange. Compare 2 and 6 less, don't exchange. Compare 6 and 4, so it is, so swap is now 0, right? Swap is now again 0, right? Because this in the outer for loop I declare swap as 0 here, right? Swap is now again become 0 here, right? Swap is now again 0 here, right? Now so I compare 1 and 2. It is 1 is already less than 2, so don't do anything. Compare 2 and 6, so same thing. Compare 6 and 4. 4 is less, so exchange, right? 1, 2, 4, 6, 7, 8. Compare, so exchange. So if I exchange, then I increment the value of swap, right? Swap now becomes 1, right? So that means now after the computation of the inner loop, I check the value of swap, but swap is now 1. So again goes back to the outer for loop. Now I becomes now 3. I can see that in this stage now I now becomes 3. Okay, so this 2 is shorted now. Okay? Now exchange, 1 comma 2. Okay, now sorry, compare 1 comma 2. One is already less than 2, so don't do anything here. Then compare 2 and 6. 2 is already less than 6, so don't do anything. Compare 6 and 4. 4 is less than 6, so exchange, right? 1, 2, 4, 6, right? Now whenever I exchange, I increment the value of swap. Swap becomes now 1. Okay. Now see. Now I can see that my array is now sorted, right? Now by following simple bubble sort, the same procedure will be repeated also here, but it is not required at all because my array is now sorted, right? So what I do, so now I becomes now, so uh, 3. So now I becomes now 2, right? Now I again compare 1 and 2. 1 is less than 2, so don't do anything. 2 and 4, so 2 is already less than 4, so nothing is changed, right? So in this case my control is not going inside the it block, right? So the swap is, the swap variable value is here not change, and it remains 0, right? Okay, now after this I check whether swap is 0 or not. So now it is true, swap is now 0. So I will get from the loop. Now I will not proceed further. So in this way I am reducing the time complexity of bubble sort. Okay, okay. So actually, so it is the so it is also called modified bubble sort. Okay. Now, can you guess the answer? What will be the base case time complexity here in the modified bubble sort? Base case time complexity. What is the base case time complexity? Yes, just find that in program, right? So uh, suppose then I have printed number of rounds, right? So I start from zero. So it will be comfortable for me to understand. I give you a class one. Okay. Then it will be comfortable for me to understand how many rounds have happened. Okay. Now, so yes, yes. Now observe the base case. What will happen in base case? So suppose 6 elements. My base case input will be 1, 2, 3, 4, 5, 6. Number of rounds is 1. Okay. So that means in yes, that means in this case the time complexity is big of 1 here, right? Right. Number of rounds is 1. Only actually one the round is equal the first round. So in the first round, I can see that there is no swapping. So I will not proceed further, right? Okay. No, it is not one because the actually the inner loop at least is functioning for the first time, right? So for I zero, the inner loop actually goes from zero to n minus one, right? So it is in the base case it is big of n, that is n times, right? Only n times only computer. So in the base case, the the inner for loop inner for loop runs for n times, right? Only once, only once, right? Only once, only once for the I equal to zero, right? So that means as a base case, the line complexity is order of n. Okay? It is called big omega of n. Okay, done. Thank you.